Almost all statistics we carry on today are based on frequentist probability. I'll show you everything you need to know about it in next 5 minutes. Frequentist believes as the number of trials increase, the relative frequency will get closer to the probability of that event. For any given event, only 1 or 2 possibilities may hold. It occurs or it does not. If a random event is repeated many times, the frequency of it will be its probability. For example, to get the defective percentage, we collect enough samples and use the defective products to divide all products. Frequentists believe there is a certain probability of every event. As long as we do enough trials, the frequency of that event is approaching the probability of it. The idea of repeating the random event many times and use the frequency of it to reveal its probability is easy to understand. However, maybe you have the doubt that frequency and probability are two totally different concepts. How can you confidently apply this theory to measure all random events? To answer this question, let me do an experiment. Toss a coin. Toss once. I get head. Can I say the probability of head is 100%? Of course not. I haven't repeated it for enough times. So toss the coin 10 times, 8 head and 2 tails. Still not 50-50 as we expected. Shall we continue? Hold on. Actually, many people have already done this before. A big thanks to them for the hard work. Now we can see that it is about 50% to see head if we repeat it enough times. Until now, I think most of you may be satisfied with the conclusion and comfortably apply it to solve your own problem. But I know some of you may ask, can you prove it? Toss the coin thousands of times. Seems aligned with your theory. But how about toss millions of times, even though the theory is true when toss the coin? Is it still true for other random events? Do you know the turkey story? On the farm, there is a smart turkey, which good at observation and deduction. It finds out there will be a farmer who brings food every morning. The turkey thinks, it seems that farmer will feed me every morning. But I won't rush to that conclusion. Let me observe it a little longer. So a year later, the smart turkey finally comfortable get the conclusion that there will be food every morning. This conclusion remains true until the Thanksgiving. Experiment can't prove the theory is right. It can only be used to prove it was wrong. We need mathematical approval. Luckily, this theory has been proved. In 1713, Swiss mathematician Bernoulli, after 20 years of hard work, proved this theorem in his book, Law of Large Number. The average of the result obtained from a large number of trials should be close to expected value, and will tend to become closer to the expected value as more trials are performed. The law of large number is the keystone of statistics and probability, because it guarantees stable long-term results for the averages of random events. Because of it, we can know for sure that it is correct to use frequency to estimate the probability. Further, under the same condition, using the historical data to predict the future is possible. It opens a door for us to understand the world. You may notice, using frequency to estimate probability is under one condition, which is repeat the trial many times. So how many times is enough? Ideally, many times equal to approach infinity. But infinity is a mathematical idea. We can't achieve it in the real world. Therefore, in order to use it, we introduce another two concepts to assist: confidence coefficient and margin of error. The law of large number tells us more trials performed, the frequency will tend to become closer to the probability. In another word, the value of frequency will bound. It is a range around the value of the probability. This range is the margin of error. For example, toss a coin. Theoretically, there will be 50% head If, from an experiment, the relative frequency of head is 52% to 48%, then we can say the margin of error is 2%. Based on the 2% margin of error, we perform the trial 100 times. If there are 96 trials are in this range, then the confidence coefficient is 96%. Thanks to the confidence coefficient and the margin of error, we can study an event's probability without infinite samples. If we use a 99.9% confidence coefficient and 2% margin of error, about 7,000 samples is enough. If we use a 95% confidence coefficient and 3% margin of error, about 1,000 samples is enough. Actually, 95% and 3% is a common standard for scientific research and statistic investigation. We will talk more about the law of large number in the next episode. I'm always here at your service. See you in the next one.